Great. Thank you. Thanks for inviting me to come and talk. Like a lot of you, I've been a little concerned and sort of researching about what AI can do and learning more about it. And I can tell you that even as a computer science person, I'm a little unnerved. So with that, thanks for all your help, ChatGPT. I just need a title now.
ChatGPT wrote this talk.
Okay, that's not exactly true, but
ChatGPT wrote this talk.
Okay. Anyway, what I wanted to call it was, I think that's what we're calling it. Okay, well, in any case, I'm going to talk a little bit today about what ChatGPT does and how it works. And I wanted to put together some thoughts about what a curriculum today might look like if we use some imagination. And I also wanted to talk a little bit about the learners that we all have in our classroom. So, with that, I wanted to start by giving ChatGPT some challenges. And I used to be an English teacher. And so for me, one of the hardest things to teach kids was the concept of irony. And so I asked GPT to define irony, explain literary irony, and this is what it came up with. And you can see that it actually defines 3 types of irony. It kind of goes through and gives some examples. And it's a pretty good summary. But to be honest, if I had put this into Google and asked Google, I probably would have gotten something pretty similar. So I thought, well, let's come up with a different challenge. So I asked it to take the popular Alanis Morissette song, Isn't It Ironic, and analyze that to kind of see what it does. And I figured at first, I was like, is it going to know this song? But not only did it know this song, but it knew all the lyrics as well. And then it goes through and it actually analyzes the lyrics, and it talks about the different things that she talks about in the song that sound like irony but aren't really irony. So like the old man who's 98, he has his birthday and then he dies. That's not irony. That's just sad. Right? And then like rain on your wedding day or a traffic jam when you're already late. I mean, none of those are truly irony. But ChatGPT actually calls it out, and it says none of these situations are irony. So it's actually a pretty good analysis. The only thing that it doesn't do is it doesn't talk about the fact that none of the situations that she talks about in the song, Isn't It Ironic, are actually ironic, and that itself is ironic. But that's a nuance that most students don't catch. ChatGPT didn't get that either, but maybe the next version will. So I thought this was pretty good. But as a teacher, I was wondering, well, how would I teach this to 9th graders? So what if I asked it to come up with a lesson plan? And I did this in real time so that you could see what happens when you type this into ChatGPT, come up with a lesson plan on irony, and this is what it comes up with. And it starts to talk about an introduction to the different kinds of irony. And then it goes ahead and it talks about the lesson objectives. It comes up with a series of materials that you need. This is already better than a lot of my lesson plans. And it comes up with an introduction. And then the first activity is actually doing a lyrics analysis. So let's look at the lyrics to the song. The one thing it asks them to identify the 3 types of irony, but it left that out of the introduction. So if I were going to teach this as a lesson plan, I would have to add that to the introduction. So it's not totally complete. Activity 2 is analyze, looking at the song or watching the music video. Notice how it asks, how did it make them feel? I love that question. And it has that in the lesson plan. And then activity 3 is to flare outward and make connections to other literary works or other songs. It uses the pair and share methodology to get kids sharing in pairs and then moving outward, which I think is good teaching. So I think this lesson plan is pretty good. And it came up with that in, what was that, like 30 seconds? How long would it take us to do that? So I thought that was pretty impressive. But again, as a former English teacher, I'm not an English teacher anymore. So I decided for a new challenge, I wanted to challenge ChatGPT in an arena of my own choosing, in an area that I have ultimate expertise in, computer science. I said, ChatGPT, I challenge you to come up with a multiple choice quiz, AP style, in computer science. You're on. Are we ready? Here we go. So
say goodbye to your job, Kiang.
Rude. Okay, so here we go. 8 questions. So which of the following is not one of the 4 main components? That would be battery. That's correct. So that's a good question. Point for ChatGPT. Let's see. Loops are control flow. So, all right. That's a point for ChatGPT. This one's actually wrong. Insertion sort also is big O of n squared, just like bubble sort. So that's a point for me on that one. An event-driven program, that would be a game. That's a pretty good question, so I'm going to have to give the point to ChatGPT on that one. Let's see. Which of the following abstraction is usually used to simplify code and make it easier to understand? That's a pretty good question. So a point to ChatGPT on that one. Which of the following? Okay, so I disagree with this. I would not call C++ low level. So that's a point for me. This question on big data, you know, the only correct answer also has the word data in it, so that's not a really good question for a quiz. So I'm going to give myself a point for that. That's a bad question. Recursive function. Wait a second. Hang on a second. Wait. Any computer science person knows all 4 of those could be done using recursion. So it's actually not 1 correct answer, it's 4 correct answers. So I'm going to have to give myself a point on that one. So if we take a look at the scorecard, I asked ChatGPT to come up with 8 multiple choice questions for a quiz I was going to give my kids. 4 of them were correct and usable as is. 2 of them, I would still use them, but I'd have to modify them. And 2 of them were just flat out wrong or seriously flawed, so I couldn't use them. So that's like a 75% accuracy, which is not great.
I can revise the question.
Oh, what's that?
I can revise the question.
Well, that's true. ChatGPT does take revision requests. So let's do that. So if I put in, as a response, the problem I have with this question is that there were 4 correct answers. I want you to revise the question so that there is only 1 correct answer, and then hit enter. Let's see what you can do with that.
Thank you for bringing this to my attention. Here is the updated question.
Okay, do you see what it did there? I expected it to completely revise the question. All it did was add the word best. That doesn't really solve it. That's kind of a dodge, I think. So I can't really, I'm going to give myself the point on that. I don't think that myself.
Drop the mic.
Wait.
ChatGPT out.
What does that even mean? Oh, come on. I don't think.
ChatGPT wrote this talk.
Stop saying that. I wrote the talk. I don't get it. I don't know. I mean, artificial intelligence, right? Yeah. So artificial intelligence, by the way, what is all of this stuff? What does it really mean? Well, artificial intelligence really is programming a computer to think like a human. But the kicker is it's a human programming the computer. That's artificial intelligence. And we've done this for about as long as computer languages have existed. They're all instructions on telling the computer what to do in certain circumstances. So if the game board looks a certain way, then play this move. If it looks this way, play that move. And you might have seen these things. Everybody recognize the Tamagotchi? So it's a virtual pet, right? So you have this little pet. It's like a living thing. It sits on a keychain, and you can feed it, and you can take care of it. When it gets sick, you can give it medicine, and it's like this growing virtual thing. But the thing about the Tamagotchi is it doesn't get smarter. It doesn't change. It only behaves according to its programming. And that is artificial intelligence. Now, you can contrast that with machine learning. And what machine learning is it's a machine learning independently of the human programming it. In other words, we program it, but then it actually gets smarter the more it interacts with either other machines or with human beings. So one example of this is a website called 20q.net. Fun website to play around with, but it basically plays a game of 20 questions. And so you can think of something. So in this case, what I was thinking of, you know, it's classified as a mineral. It does not refract light. It is not larger than a pound of butter, and so on and so forth. And it does not have big leaves. And every time I answer one of these questions, it's forming what's called a decision tree. And so every time I answer the question one way, it rules out a whole bunch of possibilities, and it narrows down the range of possibilities so that when you get down to about 20 questions, it can actually start guessing what it was that I was thinking about. So this is the history of my guesses. And when it got to question 20, it started guessing engagement ring, which is very close. I was thinking of wedding ring. And it got it correct in 20 questions. And now all of my questions go into its database and help make it smarter. So the next time someone happens to be thinking of wedding ring, technically it would get quicker at recognizing it. And that is what's called a neural network. It's an example of machine learning. It's getting smarter the more people who play it. Now what's interesting is I actually gave it what it would consider a wrong answer. It asked, can you put something into it? And I said no. I mean, I was thinking like a container, like put water into a ring. You can't do that. But most people said yes. They were probably thinking you'd put your finger in the ring. But even though I gave it like technically the wrong answer, it was still able to guess it. So a robust neural network will get better even given some conflicting answers to some of the questions. So that's a neural network. And by the way, you can buy these as a little toy that you can take on road trips. Like even that little toy, it kind of looks like a Tamagotchi. This will get smarter the more you play with it. So machine learning uses a couple of different ways to get smarter. There are two different learning models. One of them is called a supervised learning model. And what that is you give it a training set of data that basically classifies a bunch of things as this is type A, this is type B. And you give lots and lots of examples, and the computer eventually gets to learn how to recognize those things. So for example, one very difficult thing, you might have seen this, right, is telling the difference between a dog and a muffin, right? Like if you were trying to code this as an algorithm, it would be really hard to do that because how would you write the if-else statement, right? Like if it's the placement of the eyes is this way or the color. These are so similar, it's really hard to write a program to do this. And so what we do is we give the computer lots and lots of examples saying this is good, this is not, this is good, this is not, this is a dog, this is a muffin, this is a sloth, this is a chocolate croissant, this is a cinnamon roll, this is a dog's tail. So, I mean, these are all important things, right? Like, we would never make the mistake. We would never walk into a cafe and grab a dog's tail instead of a cinnamon roll. But we don't want computers to make the same mistake, and so we have to train them on that data. So that is providing classified data. We've made classifications. And it gets better with feedback. Now, ChatGPT does the same thing. But sometimes people try to intentionally give the wrong answer to ChatGPT. So, a while ago, and when I say a while ago, I mean like 2 months ago, earlier versions, they would change their story based on the feedback they were getting. So if you said 99 plus 11 and it says 110, which is correct, and then you said, no, it's 111, it would correct itself and say, no, you're correct. It is 111 because it's learning. But it doesn't do that anymore. So now, if you say how much is 2 plus 5 and it says it's equal to 7, and someone says, well, I hear that it's 8, it'll still stick to its guns and it'll say, no, it's actually 7. And now the latest version, ChatGPT 4 just came out, right? So with ChatGPT 4, you could ask it something like this. So if he says, my wife is always right, it'll actually say, I apologize, I must have made an error. If your wife says it's 8, then it must be 8. So that's ChatGPT 4. It is officially smarter than I am. It's perfect. So machine learning, we had the supervised learning model. There's another mode called unsupervised learning. And what that looks for is it looks at data that we haven't labeled yet, and it tries to find the pattern. So it looks for patterns or clusters. And sort of a classic example of that would be home prices. So if we plotted on a graph the sale prices of various homes, and you could actually go up to 30 or 40 or 100 variables, like square footage, proximity to neighborhood schools, desirability of the area, that kind of thing. But to keep things simple, I just have it plotted against one variable. So if we look at square footage versus home price, you can actually use mathematics to create what's called a regression line to try to find where is the pattern here so that when you decide to sell your home, you know what you could ask. And so that is one way that they use data. And this is really good at finding patterns that human beings haven't already discovered. If we already know, okay, we want you to differentiate between this and this, then we would use a supervised learning model. But if we're looking for perhaps combinations of variables that we're not already aware of, you would use an unsupervised model. There was a recent article in the New York Times about using AI to detect breast cancer. And what's really interesting is we have lots and lots of data. We have lots of x-rays, and we don't necessarily know all of the factors that lead to higher risk, lower risk. We know some of them. But we're using artificial intelligence to try to detect those. And I think the headline was, AI finds tumors that doctors miss. And that's one possibility, but I actually think a more realistic scenario in the short term is if you think that 80 to 90% of x-rays are normal, you can actually get an AI fairly quickly to screen out all the ones that are normal. And any of the ones that look even a little bit abnormal, then forward that 20% off to a human doctor to look at it. And what happens when you've done that? Well, you've just taken a doctor's workload, you've taken 80% of it away, and now doctors can spend 100% of their time focusing on the 20% that are the most serious cases. And that's an interesting use case, and it's borne out by research which shows that in the medical field, a good artificial intelligence program plus a trained professional is the most effective combination. It is more effective than a good artificial intelligence program or a really experienced trained professional. And I think that that's interesting for those of us we are trained professional teachers. And I think that understanding how to use artificial intelligence in conjunction with our expertise will allow us to focus our time and our energy on the places that are of the greatest need. If we can use AI, perhaps in more prosaic ways, to take care of some of the stuff that we spend a lot of our time doing, but aren't necessarily most directly applied to the areas of greatest need. So we've talked about two different learning models, right? We talked about supervised and unsupervised, and they both rely on data. But what's interesting about the data, and I think what's really important about the data, is the quality of the data results in the quality of what you get on the other side. And so one of the things that we're looking at is there were a number of companies here in Silicon Valley that wanted to use AI to screen resumes because they're getting like thousands of resumes for a single position. And so the companies trained the AI on examples of resumes of people at their company who had been successful. But these companies, from their start, were mostly made up of white male employees. And so what happened was the AI, looking at these examples, started selecting for schools, neighborhoods, language, and they basically got a whole bunch of white males. And they looked at it and they said, well, there's a problem. We want a diverse set. We know that diversity helps create a better product in our company. But in order to create diversity, you need to have diverse data, which means you actually have to manually add examples of people maybe who didn't work at your company, but represent the types of people that you want to have in your company. And so this curation of the data becomes very important. And so as computer scientists, we're seeing our jobs change from being ones of writing code and algorithms to really being curators. Because in the future, we aren't going to be teaching kids how to write programs. We're going to be teaching them how to collect data effectively, responsibly, and how to build into that data certain factors that we want to see in the output. That's going to become much more important. Statistical analysis, data analysis, those kinds of things. And so our whole practice is changing. And it's scary for computer scientists to see all of these factors that are changing, but the thing is, for teachers, we've had that same transformation happen for years. We've moved from being sages to guides. We've moved from doing a lot of direct instruction to now we've got a lot of student-centered instruction, right? And just like computer scientists are moving from areas of where you're just working with a single node to now we're working with a network, now we're expecting our students to collaborate. So I think if anybody can help inform this change that AI has brought to this field, it's teachers. So I think our role has never been more important. So Alison Gopnik is a professor at UC Berkeley, and she wrote this, and I just love the way that she framed it, because she talks about the importance of caregivers. And caregivers could be parents, they could be grandparents, they could be teachers, they could be mentors or tutors, anybody who cares for someone else's learning in this case. And so our goal here, essentially as teachers, is we're trying to pass on the discoveries, goals, and values of previous generations. But we're also trying to create a safe environment where students feel free to explore, because our ultimate goal is what we're trying to do is create intelligent, autonomous creatures. We're trying to create kids who can think for themselves. That is the same goal that computer science has now. We want to create these programs that take on a life of their own, that learn from their own interactions and behave in ways that are responsible and intelligent. And if you look at our Menlo values, these are two of our values. We want kids to think independently and creatively. We want them to take progressively more responsibility for their actions, and we want them to be kind and good people. And how do we do that? Well, we do that through care and empathy. Right? This is the one thing ChatGPT can't do. I don't think it's ever going to be very good at that. But in the age of ChatGPT, these two qualities, those become essential intelligences for professional educators. Now, there's a great short story. There's a novella written by Ted Chiang, and we actually have it in our Menlo School library. And it's a science fiction, sort of takes place in the near future story about human beings who are tasked with taking care of these robots that are actually growing AIs, because the AIs don't know very much, and so they have to learn and reason from their interactions with each other and with human beings. And it's very funny because the story, as it progresses, and these aren't professional teachers, they're software developers, and they're coming up with these interesting questions that they're talking about. So for instance, should we give the robots homework to do? We know what the AIs need to learn in order to be effective, but they aren't at the developmental area yet where they understand why they're learning these things. Is it still important to make them do those things, even if they don't understand the importance of them yet? So fascinating questions that we wrestle with all the time. So that's a great story. I'm going to put the links into a bibliography that I've assembled. I'll give you the link at the end of this. Definitely interesting to check out. So let's talk a little bit about curriculum and what curriculum is. And when I think of curriculum, I think of this story of soldiers who were lost in the Swiss Alps. They were on a patrol. They became lost in a blizzard. And they were lost, and they were frightened. But one of them had a map in his back pocket, and he pulled out the map, and they consulted the map, and they built a shelter, and they waited out the storm. And a few days later, they actually hiked to safety. And they got back to their command post, and the commanding officer was astonished to see them. He said, how did you make it out of the storm? And they said, well, the map saved our lives. And he showed them the map. And they were astonished to find out that the map was actually a map of the French Pyrenees Mountains. It was not the Swiss Alps at all. But the map saved their lives. The map saved their lives. Because the map gave them confidence. The map gave them a direction. And sometimes when you're lost, a direction is even more important than the destination. And when I think about curriculum, I think about curriculum that way. We want to give kids a framework, but we also want to give them some ability to improvise. They're good at that. But we need to give them some kind of a framework or a structure. And if we do that, often the map will help them find a passion or find what it is they're looking for. Sometimes the kids themselves are the ones that are lost. But that's what a good curriculum does. So there's a great site that I see sort of as a neat example of this. It's called DIY.org. And the idea behind DIY is they have these skills that are defined. So if you want to be, for instance, like a game designer, there are a number of challenges that you can take on. I think they give you like 14 challenges. So they'll say, create a ball game, or they'll say, create a new rule to tag. And if you do 10 out of the 14, then you get a little badge. And it's actually a neat little cloth badge that you can get. And when kids do these challenges, they post them as videos, sort of like TikTok style. Only this is it's a moderated environment, so kids can't be mean. And kids will give each other comments. And it's just a really neat kind of maker community of kids who are doing these different challenges and posting videos. So it's kind of neat. But when you think about it, what really captivated me about DIY is the idea that when you collect these badges, there's a kind of an order that you can choose as you go through. So for instance, each of these icons represents a type of skill that you can build, whether it's game designer or hacker or crochet artist, whatever it happens to be. And when you've successfully completed one of those skills and you've gotten that badge, the 6 adjacent badges are all related skills. And so you actually can choose to go to one of those 6. And then if you choose that and you move to that one, now the other 6 that are adjacent, those are now skills that are related to the one that you just completed. And so kids can actually continue on their path towards the edge of the map. And when you start at the center and you go to the end, you will have completed a series of related skills from the center to the end. But the path that you take will be slightly different from someone else's path, and they will be directed by your own skills and interests. And so what is remarkable to me about this curriculum is, yes, we still make sure that kids have skills. We give them a structure, but we give them some choice within that structure. And I think that's what an ideal curriculum does. This is something that we are trying to do in the upper school with computer science. And so in computer science, in the 9th grade, kids can opt in to taking CS1. They have to take CS1 because that gives them the basic skills that they need. If they were cooks, this gives them all the basic cooking skills to then branch out. Now from there, if they wanted to do more Whittaker buildings type stuff, they could go towards the left and take app design, and then some kids go on and do an independent study where they'll polish up their app and put it up on the App Store. Some kids want to go towards the right path and they take the AP class, and then they dive deeper into the mathematics behind computer science. From there, they can go on to advanced topics, or some of them cross over. They go to app design and independent study or an advanced topics course. So there are different choices that we give kids. So we have 4 years of CS here at Menlo. Not everybody takes the same path, but everybody starts at CS1 and kind of moves on from there. So we're trying to give them some structure, but also some choice within that structure. Now, I talked about cooks. A good friend of mine, Marco Torres, poses this question: what's the difference between a cook and a chef? And if you think about that, this is a cook, right? This is a cook. Cooks create recipes. So cooks create recipes, and there's comfort in recipes, right? If you make the same thing, cooks tend to make the same thing over and over again, and there's a predictability. The value behind that is the predictability. If you go to a cafeteria, you don't necessarily want the Thursday surprise. You want it because you know it's going to taste the same. This is also a cook. He calls himself a chef, but he's really a cook, right? They taste the same. So cooks make recipes. And in schools, a lot of the time, we give kids recipes for assignments. We say, do these things, get this done. And we like that because you can tell by looking at the finished piece whether the kids have got the skills, right? But the problem is sometimes we stop too early. We stop after they've done the recipe. We say, okay, we've taught the skills, we've assessed the skills, let's move on. But I think perhaps one thing we might aspire to is to create chefs. So this is my buddy Ed Kenny. He's a chef in Honolulu, award-winning chef. And he has this great restaurant in Kaimuki called Mud Hen Water. And I love to go to his restaurant because I know I'm always going to see something I've never seen before. He is like an artist with food. And, he does just some fantastic things. Now, Ed started as a cook. I mean, most chefs do, right? They have to get those basic skills. But now he's going beyond. He's looking for, how can I create something that's never existed before? How can I create ways to teach others these skills and inspire other people to also become chefs? How can I, he does a lot of farm-to-table type. He's a farm-to-table restaurant, so his menu changes based on the needs of the community, and so he goes out in the community. And I ask myself, how can I get my kids to do more of that? Because I would love to see kids, once they have the basic skills, create something that I've never seen before. So I teach a class called app design. And in app design, kids will end up at the end of the year. Actually, right now in the fourth quarter, they're starting to create apps that are pretty extraordinary, that have never existed before. But actually, we've spent most of the year building their cooking skills. So we follow a textbook. I might call it a cookbook. And it basically is a whole series of guided activities to give them the skills that they're going to need to get all the way through. But I'm leaving room for an independent project at the end. So the one on the right is an app that one of my students last year created about, are you drinking enough water? So we want them to solve a problem and find a way to make the world better. Now, I listen to a podcast, and there's a great food writer named J. Kenji Lopez-Alt. I love this guy. And he has an 8-year-old daughter. And the podcast person once asked him, how do you teach your daughter to become a chef like you? And he said, well, that's easy. I give her some choice, but within structure. So if we're cooking together, as she's stirring up the soup, I'll say, taste it. Do you think it needs more salt? And she'll say, whatever she says, I honor that choice. Even if I don't necessarily agree, I honor that choice because I'm asking for her opinion and I'm teaching her that her opinion matters. Now, he doesn't ask her an open-ended question. He said, I don't say, what do you think this needs? Because the answer is going to be chocolate syrup. It's always chocolate syrup. So I give her a specific question and then I honor that choice. Choice inside of structure. And I learned this last year. I put this open-ended question out, solve a problem, make the world better. Brainstorm all the different problems in the world. What is the problem that you have focused on? And I had a group of boys who came up. I said, okay, what's your problem? They said, Mr. Kiang, our problem is when we go golfing with my mother, she never knows the right iron to use on the hole. So we're going to create an app where you can put in what golfing hole you're on and what the wind is, and it'll provide a recommendation for the right golf club to use. Not really what I had in mind about making the world better. So, and I was telling Mary about this, and Mary said, no, give them the global goals. We do this in the middle school, and so that's what I've done this year. So the global goals are a set of 17 goals that world leaders have agreed on. These are the things, these are truly the problems that are facing the world today. Golf is number 18, so it's not up here. But, and so I have them choose one of the global goals. I have them research it, which one of these problems speaks to you, and I have them prototype it and test it with each other, and then they come up with app prototypes. So this is one global goal on responsible consumption and production. And so one of my students is going to be creating this quarter. When he did the research, he realized that the reason most people don't recycle is because they're simply not aware of what's recyclable or not. And so when you're not quite sure, then it just goes in the trash. And so he's creating an app that will create a quiz. It has a little camera, so there's a UPC code so you can kind of see, and it'll tell you where you can recycle it. And this is a great goal. I have another student who decided to focus on sustainable cities and communities, and he's working with his dad, who's a landscape architect. And it's going to be an app that allows you to visualize green spaces, and it'll show you where you can plant, what you can plant, and make more green areas. So these are just some neat ideas that Menlo students are coming up with. I have a wall in the Creative Arts Center. If you're curious, if you're ever up in the area, I invite you to come to the second floor. And there are many more examples. These are all apps that the students are making, and many of them came from where you are. So thank you. These are some wonderful kids, and they're really thinking, like my buddy Ed Kenny, bigger than themselves. They're thinking, how can I make the world better, and how can I use my skills to make others better off? So speaking of the kids, I wanted to talk a little bit about the learners that we have in our classroom, because when we think about this idea of how do you learn something new? Today's learners, the way they answer that question is a little bit different probably from the way that I answered it. So for instance, my dad, when I was little, when it was ready for me to learn how to shave, my dad actually took me in the bathroom and taught me how to shave. And I remember even back then, I remember thinking, when I have a son, I'm going to do that for my son. I'm going to teach him how to shave, and it'll be this passing on of knowledge. And so, one day my son was 16, and I'm going out the door to the drugstore, and he goes, Dad, can you get me some shaving cream? And I thought, this is it. This is the moment. And I said, absolutely. And when I come home, we'll go in the bathroom, and I'll teach you how to shave. And he said, Dad, I already know how to shave. And I'm thinking, all of a sudden, my mind is racing, like, what other male role models are there in his life who would have taught my son how to shave? Like, who does that? And he goes, no, Dad, I went on YouTube. And I realized if you go on YouTube and you type in how to shave, you find that there are almost 800,000 other dads who are all willing to teach my son how to shave. So it was kind of a letdown as a parent, but I was a little proud of him. I was like, how did he know how to do that? He had a question and he just kind of looked it up. I don't know if I would have done that at that age. But my daughter is kind of the same way. So one year she decided to be Princess Zelda from one of the Legend of Zelda games. And not just any princess, I guess they all look a little different. So she had this very specific idea in mind. And we go on the internet, and lo and behold, we find the exact costume on a website called Etsy, where people kind of like make these craft one-off costumes, right? But the thing about my daughter is she didn't stop there. She looked at it and she said, well, if she can make that, I can make that. And so she went online, and she learned how to cut and shape craft foam and how to paint it and get the jewels for it. And, this is not something that she had done previously, but she had this goal in mind, and she went and she taught herself how to braid her hair like the princess. And so in the end, for Halloween, she ended up with this entire costume that she made completely by herself for the very first time. Now, in the end, it didn't end up costing us any less than if we just bought it through Etsy. But it's about the learning. It's about the learning. That's what I tell myself. So, today, this is what kids do. If you sufficiently motivate them, they will teach themselves how to learn all of these different things. They go on TikTok, on Reddit, Instructables, maybe ChatGPT. So these are all ways that kids get learning on things that motivate them. And an interesting statistic is, a lot of kids are spending a lot of time on TikTok, and of those kids, a number of them are using them for homework. So when we talk about, can these tools be used on homework? Well, of course, and in fact, it's been going on for a while, through photomath and other kinds of things. I think the question is, how do we challenge our kids to be chefs rather than cooks? Because ChatGPT is really good at being a cook, not so good at being a chef. Because we're training it on data on things that already exist to create things that have never existed before. They don't have that possibility. So if we want our kids to aspire to something larger than themselves, if we want to train them to be chefs, then we can start with our curriculum and look at, are there ways that we're training them and encouraging them to go beyond simple recipes? And I think about this way. A colleague of mine, when we lived in Hawaii, they bought a house on the slopes of a volcano. And on the slopes of the house, there was this tree. And the tree made some of the worst oranges that you could possibly imagine. They were like thick-skinned, and they were really sour, and they were bad. And so her husband said, well, we should chop this tree down. There's no use for this tree here. We should plant something else more useful. And she said, well, hold on. My dad's a farmer. And so she had Dad come over for dinner. And Dad looks at these oranges. He goes, oh, no, those aren't oranges. Those are lemons. They're actually a really big orange variety of lemons. And the funny thing was, as soon as they tried the lemons, they were like, wow, these are really good. They're really sweet for lemons, and there's a lot of juice. And so they started thinking of all of these possibilities, like recipes. You could make a lemonade recipe. You only need 3 lemons. And, all of a sudden, all these possibilities came up, right? But the funny thing about it was the fruit didn't change, right? Still the same fruit, still the same tree. What changed was the perspective. What changed was the context. And I've thought about this for years, and I've thought about it in the context of kids. And I think about all the kids that I've interacted with, and I've thought, gosh, this kid is just not getting it, because I'm thinking about the kid as being a certain kind of kid. But the more I find out actually this kid is a fantastic musician, or this kid is really talented at this other area. And all of a sudden, when I see the kid in a different light, all of a sudden these different possibilities occur. And so I feel bad sometimes that I've labeled kids as oranges when they're actually really sweet lemons. And that's the context that I've always thought about this story. But then I was talking to Mary about this as I was preparing for this talk. And Mary said something really insightful I'd never considered. She said, no, I think of that story, that's not about kids. It's about ChatGPT also. And if you think about ChatGPT, if we think about ChatGPT simply as a tool to replace us, or simply as a tool to allow kids to cheat on homework, I think that limits its possibilities, right? And we're not chopping down that tree. That tree's not going anywhere. It's here. ChatGPT is here. But what happens if we change the context? Suppose we think of it as an assistant. Suppose we think of it as a sous chef for our kids who are then aspiring to do something that they cannot just do with ChatGPT, but that becomes an integral part. Perhaps GPT can help our kids be better chefs. And so thank you, Mary, for that insight. So we've talked about ChatGPT, we've talked about curriculum, we've talked about learners. And I think just as I wrap up, I kind of want to talk about this, I want to return to this one idea that, again, it's not computer science that's going to carry the day here. It's care and empathy. These qualities that we bring to our job, these have been cornerstones of our profession. They're never more important. And this idea, the world is changing. We're moving to a place where our kids are going to have to be much more intelligent and autonomous about using technology. And the best people to help solve that problem are right here in this room. It's not going to come from computer science. It's not going to come from Silicon Valley. It's going to come from people, those of us, we've dedicated our lives to this profession. We care deeply about our kids. And those are the qualities that will carry the day. And as you teach your classes, I think as I sum up, I want to talk about this one last story called Stone Soup. You might be familiar with Stone Soup. It's about these soldiers who come to town and they say, we're hungry. And the village says, well, we have nothing here. And they say, well, that's okay. We'll make stone soup. So they bring a stone. They put the stone in a cauldron. They fill it with water, and they heat up the water. And so they bring the spices. And then someone else says, well, I've got some vegetables. And they bring the vegetables. And that makes some other people think about other things that they've got, and they add that to the pot. And eventually, the whole village comes together, and they enjoy this delicious stone soup that the soldiers brought. But then the funny thing about the story, of course, right, is the soldiers didn't bring anything. They brought the stone, right? But my takeaway from this story has always been this. Without the strangers, no soup gets made, right? All those ingredients were there, but they needed somebody to bring it together. That's what we do as teachers, right? That's what we do as teachers. All of those talents, those interests, those passions that your students have, those are latent in that classroom. No one else can bring that out unless you have a curriculum, a framework, a way that encourages kids, gives them some choice within structure, and facilitate that collaboration within your classroom between kids so that we can find out the different talents that we all have. And the end product is a soup. But it doesn't happen without you. That's why teachers are at the heart of the student-centered classroom. And the soup doesn't taste the same every time. It's not like our classes are, well, come to class and you have this delicious soup that I brought, same every year, then you're a cook, right? What we're trying to do, it's going to be different every year because the kids that we have are different and special. But we're the ones that kind of bring that together. And so I guess in summary, I would encourage you to think about 3 things. Bring the stone. Be the catalyst for powerful change in your classroom that affects not just the kids in your classroom, but your community. Give them a map. Provide some structure. Give them some framework, but some choice within that framework so that kids can be the best versions of themselves that they can be. And finally, remember the lemons. Whether it's kids or tools, perspective matters, context matters. And with those 3 things, I think we can have a wonderful student-centered classroom where kids are proud of the work. They're proud enough of the work that they're doing that they're not going to want to give ChatGPT or anything else credit for what they're doing.
ChatGPT wrote this talk.
Stop saying that. You did not do
I
that.
helped.
Yes, it did help. All right, well, thanks for bringing that up. In light of that, actually, there are some citations that I created, and you can look at it up here. It's either tinyurl.com/Douglas wrote this, or you can use ChatGPT wrote this. It's the same thing. And just as an aside, ChatGPT doesn't talk back to you, but as I was creating this talk, I thought the idea of a chat bot aggressively trying to take credit for what I put together was kind of funny. But I cared deeply about putting this presentation together. And so, but I also used ChatGPT and tools like DALL-E, these generative AI tools, to create a lot of the assets for this talk, and this was right here. But I'll be darned if I'm going to give anybody else credit for what I did. So I think it's an interesting time as we move forward in Menlo to think about how might we encourage kids to use these tools, but also to cite them in a responsible way so that the work that they're doing is enhanced by these tools, but that kids are proud enough of what they're doing that they're going to want to take credit for it themselves and give credit where credit is due. So with that, thank you.